recording. So I am, what is one of the advantages, one of the advantages for me personally in terms of my sanity with these Slack channels and having the groups here is to see how you actually help each other out. If somebody asks a question in a group, there's always people prepared to help out with the code, and that is really, you guys give me hope for humanity, the way you participate and help your friends or even people that you, I think, may not know. So my suggestion is, your friends, some of them will be able to code this better and more neatly. And so keep on asking about it. But I had some questions regarding how do I now solve that. Let me just have this screen up again. There at page, there we go. How do I solve that part D? Where I said you now have to choose a range of T0 values. Everything else is specified, so your steam to EB ratio is fixed, and all your other inlet conditions, if I'm not fixed, I can change that. And I want to optimize from my reactor. I want to optimize my styrene flow rate from the reactor. How do I employ this in code? So many of you, well, if you can do the online test, you will be able, for a T0 value, you should be able to solve all those styrene flow rates by employing solve IVP with a specific T0 value in your inlet range. So now I can, of course, do it manually. I can choose different T0 values. I can in Excel go and have a list of T0 values, and I can just change it in the Python, and for all the different T0 values, I can calculate styrene out, and I can go and type it in Excel. I can calculate my temperature out, pressure out, everything out of my reactor and record it in Excel. And then I can construct a plot of what is my styrene flow rate out versus my inlet, choice of my inlet temperature for my reactant mixture. And then you can go and see where is that maximum, and you can record that corresponding value. So you run your solve IVP 1,000 times by changing the T0 value. So now we just like to automate that. So where is my screen now? There. Okay. So this is my differential equations function. So I just return that, and I can now use solve IVP to solve the DEs. All that it needs is that volume limits, and the volume limit is fixed. That's 10 cubic meters per hour. Per hour, my word. It was specified as 10 cubic meters. And the thing that is going to change is my var naught value. So my inlet array, this is going to be the same, the steam initial ratio, that's the way I specified that. So ST is my steam. So that's based on that ratio that was specified. And T0 is now going to change in my inlet variable array. So I still have my limits, and I am going to, for inlet temperatures of a certain range of values, I want to calculate and collect the outlet values for styrene, outlet temperature. I can add something here. I can say I want, oops, daisy, what's happening? Oh, I've got numlock on. Hang on, sorry, different keyboard. I'm looking like tech support here. So my pressure out, I can also specify an empty list over here. And then for change T0 to be all those values that is in the space list. And I can increase the number of T0 values for which I want Python to repeat this by, of course, adding a different amount of steps there. So I will have 100 T in values. For every T in, it's going to make T0 that value T in. And what is going to change? My var naught must have that T0. So that is just copied and pasted from my previous procedure where I solved for the outlet flow rates. I've got my output that I'm going to ask solve IVP now go and differentiate this, but do it over and over and over and over again. Dense output here is optional because I'm not going to plot anything in this for loop. So all I am actually interested in. It's just because I just copied and pasted. So I can make life easier for Python and just stop the brackets over there, but I have got no sympathy for Python. It made me suffer too frequently in the past, so let it suffer. I can wait a few seconds for my code to run. So I now have calculated that all those values, but I'm only interested in the last one because I'm only interested in the outlet value. That is what I want to append my lists with. And so now I just use the append function. So if styrene, that one, append with whatever styrene is over here. My variable name for styrene was styrene. And the temperature out, I appended. I calculated the selectivity. I wanted to calculate that. I also just have for instance, P out that I can append. And that is going to be equal to my pressure value. So please note that here I don't have, and when I plotted for my previous cuts, for instance, A, B, and C, I collected all our dense output and I ran this var out and I've got a whole array of values for EB, styrene, whatever. So please note that now I just ask Python to associate each of these variables with just the last value that it got for each of the differential equations, or the output from the differential equations in my solution. So now I appended that, and I can now just run this, okay? And now I can plot that temperature in values, that list, that I asked for Python to calculate for each of my changing inlet temperature values. I can now plot it in terms of my styrene flow rate. So this is the resultant plot, okay? And now I can see there's actually a maximum. So let's just change this. If I now chose an incorrect temperature range, so let's just say I'm going to go from 850 to 900 Kelvin. And just let's see how that looks. So this is, okay, sorry, it's without proper, still some residual there. Okay, so there we've got our styrene flow rate out, and over here I've got my my inlet temperature, and you can see that if it does performs this code correctly, the maximum styrene flow rate just occurs at the warmest inlet temperature value, which is my 900 that I selected, and that makes sense. So if I now increase my range, I can see that there we go, run, that is good. The graph looks different because it automatically adjusts this Y value unless I give it some limits, of course. And now it finds values, but please note what happens now. So I now choose where is that at a maximum, where is my styrene at a maximum, and find that Tn value using the this search variable. They must have, of course, be equal arrays. Find the value for F temperature in where F styrene is equal to that maximum value, and then it's going to find that maximum value. Note what happens if I now change this value to 1,000. I hope it's going to change. Can you see there? So people ask me about the accuracy of these answers. Depends on these boundaries. Let me just zoom in a bit. So let's say I want to go from 900 to 1,000. Ching, ching. And then it gives me 994. Let me go from 950 to 1,000. 950. Ding, ding. 994. That seems to be the one on which it kind of settles. So we will get different answers based on those ranges. You will also get variation in answers, whether you choose for your molar flow rates it in moles per second or kilomoles per second, just like in some of the previous tuts. So you can expect some variation in the answers in your whole answer set for TUT 5. Okay, so that is what I wanted to show you. I'm going to stop the recording. Let me just go there and stop sharing my screen. Right, so now if you want to type questions, any questions?